Good evening all. I welcome you all on the behalf of StudyIQ English IAS. My name is Pritesh Maturkar. I welcome you all to this exemplary journey entitled Geography Through Maps. On behalf of StudyIQ English IAS, I extend my warmest regards to everyone. In this journey, I will be your guided tour mentor, I will be your philosopher, and I will be your most able friend for roaming the world, for covering the different destinations on the world, and using the most potent tool in geography, which is called as maps. We will try to analyze the complete world's physiography. We'll try to paint a picture of a discipline called as geography. Okay. Tools are very important for deciphering any content. In geography, the most important tool has been maps. Since ancient times, the people have been relying on maps for going from one place to another. And in maps, as the detailed increase, as people ventured into different cultures, different physiographies, so detail of maps also increase. So this will be my endeavor with all of you. Those of you who are watching me for the first time today, I welcome you all to this journey. Those of you who are continuing with me since day one, again, welcome to all. Okay. Hello, Girish. Welcome. And what I intend to do basically in this journey are two things primarily. First of all, I tend to cover the basics of discipline of geography so that using this curriculum, you can cover approximately 50 to 60% of your basic GS discourse. And using this knowledge, you can even learn the advanced discourse of geography too. Okay, so this is my primary purpose. The second purpose is that using this knowledge, whatever you will get in these sessions, I wish, rather I have faith that those who will be there with me till the end of the sessions, you will be easily scoring 15 to 20 marks in prelims and approximately 100 to 200 marks in your mains. And if essay is coming in your purview, that will go even further. Okay, so the coverage which I will be having in these lectures will be primarily based on the discussions of the NCERTs, primarily the NCERTs of 11th standard, the World Physical Environment and India Physical Setting, and a book entitled Certificate Physical and Human Geography by Goncheng Leon. So that will be our primary discourse in this curriculum. And most importantly, guys, I want each and every one of you to utilize this content. Any content that you watch on the screens, on your mobile screens, on your laptop will be of no use if you are not able to utilize that content. So please utilize this content from a utilitarian perspective in both prelims as well as mains. And guys, I'm being adamant since day one, please be hungry for marks. Okay, I will again like to quote the great Viru Sahasrabuddhe virus from 3 Idiots movie. Life is like a race. If you don't run fast, you are like a broken anda. Okay, so that is all. In UPSC, you will have to crush the competition. In the examination of civil service examination, you will have to crush the competition. You will have to move ahead of others with flying colors, and for that you need some good content, and that will be my ultimate endeavor with each and every one of you. And the flow of lectures will be like this, that in each lecture, in the starting 5 to 10 minutes, I will be doing a quick recap of whatever we did in the previous lectures, and after that I will keep on building the concepts, and once the concepts are built, we will utilize them on maps. Okay, so first 20 to 30 lectures will be based like this only. I will not go into the detailed discussion of maps per se, but once our basic concepts are built up, once you know what is going on geophysically on the earth, then I will open up the maps for you all. So I will open up the Pandora's box, and then we will start our actual world tour. I have started the world tour for each and every one of you, but we have started it on a rather small scale. Slowly we'll move. So you and me, we both have to learn in the sense that I also learn from you, you also learn from me. So this is a marathon, guys. This is not a sprint race. Please understand this fact. You and me are both running in a marathon. We are not running in a sprint race where by just watching these lectures in 1 hour, you will become the master of geography. No. And that should not be your aim. Your aim should be that you and me will both work together and will both set through together. So as promised, I'm starting again my lecture by showcasing you one of the most beautiful locations that I have encountered in my life. and one of the locations which we did in the previous classes. So the board which you are seeing, the location which you are seeing on the screen, okay, so this is called as a mushroom cloud, okay, and the topography which you are seeing over here, it is the topography of Virunga National Park. You must be remembering the Virunga National Park from the equatorial regions perspective, okay. So we did it when we did the dense equatorial rainforest when we were traversing through the Democratic Republic of Congo and the surrounding regions of it, okay. So Virunga National Park is very much in news. Why? Because the government has opened the park for coal mining. So see this beautiful topography, this mushroom cloud over Virunga National Park, we don't know where it will go in the future. I just pray that the luxuries of the European countries don't end up destroying this beautiful topography. And guys, this is how you should study geography. This is how you should approach geography. Once you see a beautiful image, okay, it gets imbibed in your brain, guys. And that's the beauty of this discipline, that you can actually see, and rather sometimes you can actually feel what is happening on earth too, okay. So this is how beautiful the Virunga National Park is, okay. And you must have heard the famous gorilla selfie, okay. That picture went viral all over the world, okay. So it was also taken over here only, okay. So let's move ahead. Let me just quickly introduce myself, guys, so that we can start our lectures. Those of you who are watching me for the first time, or those who are continually watching me, my name is Pritesh Maturkar, okay. I will be your primary faculty for handling the geography GS perspective. So treat this as the guiding sessions for your main syllabus, okay. You can reach out to me on Telegram. The name of the channel is Geography by Pritesh Maturkar. You just do a global search on Telegram @geography by Pritesh. My bad, it's not @, it's just @geography by Pritesh. So on this Telegram channel, I keep on posting the relevant tidbits. I keep on posting some good PDFs, and I also keep on posting some of the discussions with regards to whatever is happening in the world of geography. So all of you are free to join this channel, and don't worry, okay, I don't bombard you with knowledge, I don't bombard you with the information, okay. It's just one article one day, two article one day, not more than that. So it's, guys, slow but steady will always win the race, okay. So before any further ado, let's begin our today's discussion. Let us build upon from where we left in the previous class. Let me just quickly do a recap for you all. So in the last class, I introduced you to the concept of the polar vortex, okay. Those of you who are joining me today, you can jot down this point so that whenever you will see the previous lectures, you will focus on this. I explained you a concept called as the Coriolis force and its connection with the latitude, okay. I will quickly revise what do you mean by this. And we also did the westerlies wind, okay. And we also tried to interlink the weather of 40° north and above with what? With the vegetation, okay. So I will just quickly revise whatever we did in the previous classes, okay. So in the previous class, I introduced you to a thing called as polar vortex. For that, we need to have a detailed discussion of the Coriolis force per se. So what is Coriolis force? Coriolis force is nothing but a apparent force. Why this force comes into play? This force comes into play because of the rotation of Earth on its axis from west to east, okay. Because of this, what happens? The bodies, they tend to deflect right in the northern hemisphere and left in the southern hemisphere, and hence, because of this apparent deflection in the horizontal movement, the air, instead of rising from the equator and sinking at the poles, it rather sinks at the subtropical latitudes and it comes back towards the equator, completing the first cell, that is the Hadley's cell. another arm will move towards the 60 degree to 65 degrees north, where it will meet the cold air coming from the poles. So two more vertical circulation cells will be completing, called as the ferrule cell and the polar cell. And I taught you that out of these three cells, only the Hadley cell is a thermally induced cell. Rest of the two are dynamically induced cell. Okay. And the Coriolis force has got to do what? Coriolis force has a sine angle component with the latitude. Sine angle component means what? That if you consider the Coriolis force at equator, so sine 0 will be equaling 0. Whereas if you consider the Coriolis force at the poles per se, so sine 90 will be equaling 1. So Coriolis force will increase from equator towards the poles. The answer is simple. Why? Because as you move from equator towards the poles, the radial distance of the surface of the earth from the earth's axis, it decreases. Okay, so the deflection tends to be more, so as to conserve the angular momentum. Okay, so Coriolis force will be maximum at the poles per se. So any wind which starts from the poles, if it starts to come towards the subpolar low pressure belt, it deflects, where it will deflect towards its right in the northern hemisphere and towards its left in the southern hemisphere. So anywhere you go around the poles, you will find a closed circular loop of circulation called as polar vortex. So this results into what, guys? This results into the cold polar air being trapped over the poles itself. Now because of climate change, now because of global warming, this polar vortex is swirling down southwards. It is sometimes breaking up too. Okay, so because of this breaking up, what is happening? Okay, because of this breaking up, you have cold waves far south, even towards the tropical areas too. Okay, the famous cold wave of the North America of the year 2019 and 2020 is a living evidence for this. Okay, so the climate change, global warming are all causing havoc to the earth per se, and it can sometimes break the polar vortex too. Okay, and last thing that I discussed, that if you go towards the 60 degrees to 65 degrees north, so there what is happening? You are having the cold Arctic air coming from above, and you are having the warm tropical air coming from below. And where these two air will meet, where these two air masses will meet, there you will have a thing called as fronts. Okay, very crude definition of fronts. So let us now continue our discussion from here only, so that I try to paint a picture of the vegetation at around 60 to 65 degrees north and between 60 degree to 70 degree north. Okay, if I consider 60 to 70 degrees south, do you have any land? You don't have any land. You predominantly have what? You predominantly have oceans. So but naturally we have to consider the northern hemisphere only. So I did the vegetation of equatorial areas, I did the vegetation of the tropical areas, we did the vegetation of the desert areas, we did the vegetation with regards to the western coasts of temperate lands, where if you have westerly winds and here you have mountains, so you can have temperate evergreen vegetation too. So I will repeat those concepts for you all again, so that you have working understanding, and slowly we'll build up the concepts even more. So once we are done with this, then I will introduce you to some of the basics of the Earth's lithosphere, which I think are important from the maps perspective, and I will also introduce you to the basics of oceanography, the hydrosphere per se, which I feel are important. So once our conceptual building is done, okay, like it's like cooking biryani, guys. So first of all, you will pour some water, you will pour some oil, you will pour the spices, you will pour some ghee in it, okay, and then you will start pouring rice, then you will start pouring meat, and then you will let it cook. So first of all, we need to make the base for the mapping exercise. So treat these lectures as the base for mapping, wherein using this base, you will start analyzing the world through maps first. And I hope that everyone is comfortable with me. Those of you who are watching me live right now, you are free to comment. I will be always receptive from your end, and those of you who will see me here afterwards, as per your convenience, you are free to comment too. And guys, I am a receptive faculty. I am not a one-way communication. It's a duplex communication. Okay, so it's up to you. I know it's incredibly difficult to learn geography in this way on a digital screen, but StudyIQ IAS English will do its best that you will get the best content with the best possible faculty and in the best way in the best manner possible. That's our commitment to him. Okay, so now let me just open up the world map for you. So where will we now discussing the temperate areas vegetation and the vegetation of the 60 to 65 degrees north and between 70 degrees. Okay. So if I open up the world map for you all, okay, so first of all I will be using a 2D map and then we'll migrate towards a 3D map. Okay. So first of all, now I'm focusing on the latitudes 60 to 65 degrees north and above. Okay, so for your reference I will be drawing over here. Okay, 65 to 60-degree north. Okay, so I'm considering first predominantly Europe, and then we'll move towards discussion of North America and east of Asia too. Okay, because like the landmass of Europe is ample enough to understand what is happening, so that we can build up upon these concepts even further. Okay. So I'm considering this particular latitude, guys. This particular latitude for you all. So let us do this latitude from the European perspective as well as from the Eurasian perspective. Okay. So if I'm considering this latitude, now what is happening at this latitude? You have the warm tropical air coming like this, and you also have the cold polar air or the cold Arctic air coming like this. So actually what is happening at this latitude? Okay, here you have subpolar low pressure belt where the air is forced to uplift. Okay, you all know that this region is a region of the subpolar low pressure belt where the air is forced to uplift. As the air is forced to uplift, but naturally as the air will rise up, the water vapor inside the air will condense and you will have rainfall. But additionally, what is happening at these latitudes is this phenomenon. Okay, so this is what, this is warm air. Okay, this is what, this is cold air. Okay, this warm and cold air, this warm and cold air will do what? This warm and cold air will start interacting along this latitude. Okay, so the warm air mass can come from the Atlantic Ocean, it can come from the Saharan region, whereas the cold air mass will come from the Arctic or the polar region. Right now, guys, I am not giving you the definition of air mass because it's a little bit technical definition. Just now consider that air mass is a big chunk of air, is a very huge area of air, is a huge space of air where you have uniform properties of pressure and temperature. Okay, I'm again reiterating. What is a air mass, guys? Air mass is nothing but a huge chunk of air, huge space of air, which will have uniform properties of pressure and temperature. So if the air mass is coming from the Atlantic Ocean, so but naturally it's warmer. Okay, water being there, so you will have stable air over that and the air will be warmer. And if a cold air mass is coming from Arctic region, its pressure and temperature will of course be less. The temperature will be less, but the pressure will be high because the air will be somewhat subdued as compared to the low pressure area of the Arctic region, of the Atlantic Ocean. So where these two air masses meet, where these two different types of air masses meet, there you have a phenomenon called as fronts. There you have phenomenon called as fronts. Okay, what are fronts, guys? Okay, very crude definition of fronts. Definition of fronts is in this way. Fronts are nothing but what? They are the boundary. They are the boundary. They are the boundary or zone of interaction. They are the boundary or zone of interaction. Zone of interaction. They are the boundary or zone of interaction of what? Of two contrasting air masses. Okay, two contrasting air masses are the fronts or the boundaries of interaction of what? Of two contrasting air masses. So what does this mean? that whenever you will have warm air which is coming from the subtropical areas, and whenever you will have the cold air which is coming from the arctic areas, wherever you will have the zone of interaction, you will have formation of fronts, and the weather along the fronts will be very unstable. Why? Because warm air will try to rise up, whereas cold air will try to descend. Okay, you all know warm air is light, warm air is little bit expanding, whereas cold air is dense, it will try to contract. So just imagine two contrasting properties are meeting. Just imagine that you are having two people of contrasting nature which are coming together. So but naturally you will have friend formation between those people. Just imagine you are interacting with a person whom you dislike, whom you like the least, because your thought process and that person's thought process does not match. So but naturally you are going to have frontal interaction with that person. Okay, you say no, okay, come and say to me, I'm standing now, see, this is the front where you and me will interact, speak face to face. Okay, that is what is happening over here. The cold air is saying come and meet me, the warm Atlantic air, and the warm Atlantic air is saying yes, I'm coming and meeting you, wait. Okay, so here you will have what? Here you will have very unstable weather. So because of this instability, because of this somewhat low pressure conditions, the air will rise up, and whatever moisture is present in that air, it will condense and it will fall down in the form of precipitation. And this precipitation will be fairly constant throughout the year, guys. I'm again reiterating, this precipitation will be fairly constant throughout the year. So because of this, what will happen if the precipitation is constant? So here again you will have evergreen vegetation. Why? Because throughout the year you are having rainfall. Mind you, that rainfall is not as heavy as the equatorial areas. Okay, this is different, guys. Okay, the rainfall in the equatorial areas is entirely different as compared to the rainfall in this latitudes. Okay, the equatorial rainfall, it is referred to as the convectional rainfall, where you have the vertical convection of air because of direct insolation of the sun, whereas the rainfall of this latitude, it is called as frontal rainfall. What it is called as, guys? It is called as frontal rainfall. Why? Because here two air masses of contrasting properties are coming and interacting with one another. So the rainfall will be very less as compared to the equatorial areas, but this rainfall will be fairly present throughout the year. Of course, in winters, instead of rain, you will have snow. Hence, you go in this area, so you will find the coniferous trees covered in snow. And hence, if you see this area now, okay, if I'm rubbing this, so if I'm rubbing this, if you see this particular area, let me just clear everything. Okay, so if you see this particular area on your atlas, this particular area, see how dark green it is. Okay, indicating what? That the vegetation in this part of the world is evergreen. Is evergreen. Okay, it will be green throughout the year, but this vegetation is not the same as the equatorial regions. Why? Because here you will have what kind of trees? You will have coniferous trees. Because in general, as we move from equator towards the poles, the temperature will decrease because of latitudinal zonation of temperature, and hence you will have predominantly coniferous trees. The one word for this is, okay, okay, let's test your general knowledge. Those who are seeing me or those who are watching me live right now, try to comment. Okay, what is the vegetation of this commonly referred to? The term starts with T. Okay, I will be waiting for that answer. So just 5 to 10 seconds. Let me just now move my discussion to the other areas too. Let me just give you a very good example of temperate evergreen rainforests. Okay, so I'm waiting for your answer, guys. See if you can get the answer. So just 5 to 10 seconds. Anybody who is watching, you are free to comment in the comment box. Okay, if you see this dense evergreen belt, and mind you, this dense evergreen belt is fairly constant throughout the world. Okay, the name of the vegetation of this belt, it is called as taiga. Okay, taiga vegetation, where you have evergreen coniferous trees present throughout the. Yes, Vishnu, you are right. Okay, it is called as taiga. Okay, okay. So anywhere you go on the globe, anywhere. Okay. So again, let me open up the Earth for you, but now let's open up the map of Earth in 3D. Okay. So let us move towards North America first. Okay. Okay. So if you see this part of North America, see this part is again very dark green, indicating what? Again, you are having here evergreen vegetation. Okay. And again, this is taiga belt. Okay, taiga belt. Why again? Here you will have frontal interaction. The cold air coming from the poles will interact with the warm air coming from the tropical areas. Very simple explanation, guys. You don't need to get into details of it. You will be taught everything in your mains discourse. Right now, just understand this, that here, why do you have evergreen belt? Because of frontal action. Okay, frontogenesis. It is called as frontogenesis, where the contrasting properties of two air masses, they start interacting, forming fronts and causing very unstable weather. So I bet that this is now comfortable with you all with regards to North America. If I switch my discussion towards the Europe, okay, so again, if I'm focusing on Europe per se, okay, again, if you see this complete belt in Europe, this complete belt in Europe as well as in the Siberia. So this is Europe. Okay, this is Siberia. Okay, so you will have what? You will have one continuous stretch of taiga vegetation from the Pacific to Atlantic to again to Pacific. So it's a circumnavigating belt of vegetation. Anywhere you go between 60 to 70 degrees north, between 60 to, there I say to be very precise, between 58 degree to 68 degree. I am giving you the exact latitudes of taiga vegetation. Between 58 degree to roughly 68 degree, you will find dense evergreen coniferous forest called as taiga vegetation. Anywhere on the globe, predominantly in the northern hemisphere. Why don't we have this in the southern hemisphere? Please understand now. Okay. So if I move my discussion towards the discussion of the southern hemisphere, let me again use the 2D map. Okay. So if I'm considering the southern hemisphere, now see the southern hemisphere. Okay. If you see southern hemisphere between these latitudes, okay, what do you find? You find predominantly the oceans. Okay. So as you all know, water will try to do what? Water will try to moderate the temperature conditions. So because of this, taiga belt is totally absent in the southern latitude. Okay. Why? Because you don't have any land. It is the predominance of the oceans per se. So please get this info very, very properly. So I hope this discussion is now fine. Now guys, I am now increasing a discussion level even more further. So I will be discussing a mains question now, which came just 2 years back, that how do the local mountains or how do the local orogeny affect the weather and climate of the place locally. Okay, so please focus on the board for a moment for understanding what do you mean by this. Then I will explain you the concept of temperate, dense, evergreen rainforest. Okay, see, whenever the word evergreen will come, first of all, it should click in your mind. Okay, evergreen, rainfall very heavy. Throughout the year, the vegetation is green, meaning what? That the rainfall is fairly present throughout the year. So how come temperate areas have this? Okay, the answer is linked to the local orogeny and the influence of the westerly winds. Okay, so let's move ahead with our discussion and let us see that also. So for that, again, I will be using some diagrams to focus on the board very, very properly. Okay, so now if I'm considering any elevation, okay, if I'm considering any mountain, okay, so mountain is basically a elevation which is more than 1,000 meters of height. Anything less than 1,000 meters, it is called as hill. Anything less than 650 meters, it is called as hillock. Okay, so mountain, hills, hillocks. I will write it for you. You have mountains, you have hills, and you have hillocks. Okay, so mountain is what? Any elevation, any elevation, any elevation which is more than 1000 meters, it will be called as mountain. Any elevation which is less than 1000 meters but more than 650 meters, it will be called as hills. And any elevation which is less than 650 meters, it will be called as hillock. It will be called as what? Hillock. So consider now the mountains. So any elevation more than 1000 meters. So if I'm considering this to be a elevation of more than 1000 meters, okay, and if you have wind coming like this, okay, this is the direction of wind, and here you have the water body, here you have the oceans like this, okay. So this side of the mountain which is facing the wind, this side is called as orographic side. This side is called as orographic side. The side which is facing away from the wind direction and which is facing towards the land, or which is opposite to this side is called as leeward side. This side is called as leeward side. Okay, so orographic side and leeward side. This is orographic side and leeward side. So now just imagine that this is an elevation, and this elevation is resulting into what? This elevation is obstructing the wind which is coming from the ocean, and this wind is moisture laden wind. Mind you, this wind is what? This wind is moisture laden wind. So you will have what? You will have dense, you will have not dense, you will have heavy downpour. You will have heavy downpour on the orographic side. Why? Because as soon as the wind will start to rise up, so if I'm showcasing you exactly what will happen, okay, so as soon as the wind will try to rise up, okay, the wind is being obstructed. Now the wind is trying to rise up along the slopes. So as soon as the wind will try to rise, it will condensate. Okay, it will condensate. Okay, it will cool down, and whatever moisture is present in this wind, it will come down as rainfall. It will come down as rainfall. So now just imagine globally, wherever you will have this kind of arrangement where mountains are acting as orographic barriers to the incoming wind, what will happen on this side? You will have evergreen rainforests. And if this arrangement is obstructing a global planetary wind like westerly wind, okay, and if the westerly winds are coming from the Pacific, if the westerly winds are coming from ocean called as, from a sea called as Tasman Sea, which will have very good moisture laden in themselves, so you will have dense evergreen temperate vegetation. Why? Because on their coast you have mountains. So what are the mountains and what are the coast? Now that I will be highlighting. And mind you guys, this is the side of orography. What will happen on the leeward side? As soon as the wind will cross over this side, the air will do what? The air will start descending. Okay, and as the air will start descending, it will get compressed. Okay, and because of this compression, the temperature of the air pocket will increase. Okay, no, my bad. If the air is getting compressed, if it is getting compressed, the temperature of the air pocket will get what? So if the air descends, it becomes cold. Okay, so the air over this side, it will start becoming cold. It will desiccate out. So on this side, you will have heavy downpour. On this side, you will have what? Very scanty rainfall. You will have very scanty rainfall, and hence on the leeward side of the mountains, you will predominantly have what? You will predominantly have grassland. You will predominantly have what? You will predominantly have grasslands. Okay, you will predominantly have grassland. So this is the common arrangement of the topography on some of the temperate western coast, and this was the same question which was asked in the mains. How do the local orogeny, or how do the local mountains affect the weather and climate of that particular place and what are its consequences on the vegetation. So on the orographic side, you will find very dense forest, whereas on the leeward side, you will find what? You will find grasslands. So now let us discuss those areas where you find such kind of arrangement, guys. Okay, so for that, I'm again using the maps. Okay, so let me now open up the maps for you all again. Okay, let me use the earth in 3D so that you even get a better picture. Okay. Okay, so if we consider the North America, okay, so on the west coast of North America, you have a mountain range called as Rockies. Okay, guys, all these mountain ranges we will discuss in detail when we will do the North America physical. You don't need to worry. Now you just need to understand what is happening, because once your concepts are clear, once you get the hang of these concepts, you will be pretty comfortable with handling the information. Okay, so Rockies, and on the this side you have a mountain complex called as the Pacific, Northwestern Mountain Complex. So there are 3 to 4 ranges in this Pacific Northwestern Mountain Complex. Okay, so now you all know that this region is the region of what? This region is the region of westerly winds. Westerly winds will do what? They will pick up the moisture from the Pacific Ocean and they will start moving towards the western coast of North America. So now just imagine a westerly winds coming and hitting this region like this. So what will the Pacific Northwestern Mountain Complex do? What will be the Rockies be doing? They will acting as what? They will be acting as orographic barriers to the oncoming of westerly winds. Hence, this region of the world, this coast of the world, here you will find a thing called as, just do it above. Here you will find a unique phenomenon called as temperate evergreen rainforests. This will be the predominant area of the temperate evergreen rainforest, and because of this, because of the oncoming of the westerlies and these westerlies being planetary winds, this means that these winds move throughout the year. They move 365 days a year. So you will have incessant rain over this part of the world, and hence because of this you will have the world's tallest trees, the world's tallest trees in this part of the globe. World's tallest trees. Okay, because of this intense downpour, you will have the world's tallest trees. Those who are watching, you are free to comment if you know the name of this. Okay, the name of the world's tallest trees, it is called as the giant redwood. It is called as the giant what? Redwood. Okay, giant redwood tree of California, of Washington, of Oregon. These are the world's tallest trees. And why do we have this? Why do we have this arrangement? Because the mountains on the west coast are acting as orographic barriers. Okay, and now as soon as you move from the mountains towards the east side, okay, if you come in this part of the America, okay, if you come in this part of America, this is where you will have the temperate grasslands of America. These grasslands will be called as prairies. These grasslands will be called as prairies. These grasslands will be called as what? These grasslands will be called as prairies. Okay, the temperate grasslands of North America. And why do you have this arrangement? Because the mountains on the coast side are acting as orographic barriers to the winds that are coming from the Atlantic, the westerly winds, and hence because of this, whatever you have on the east side of these mountains is grasslands. Okay, so I hope that this concept is clear to you. Now let us apply this concept even to South America, and let us try to use this concept even in Europe, even in Africa, and even in Australia and New Zealand. Okay, so guys, I hope that you are enjoying this interactive way of learning. Okay, when I was preparing for civil services, we didn't have such interactive kind of learning, but I hope that this image is now getting imbibed in your brain, and I hope that I'm doing justice to your preparation. Okay, with times the technology evolves, with times the lecturers do evolve, so I have also evolved through time. Now this being a time when we have traveled from a era of pandemic to an era of endemic, and you know what COVID has done to everyone. So even the professors like us, we need to evolve with time. And guys, it's your humble duty too that you also evolve with time. And I hope that this is one of the best methods of learning which you can get, interactive learning. Okay, so I hope that everyone is enjoying, and please register this image in your brain. Okay, you will not remember what you have written, you will not remember what you have summarized. What you will remember, my words, you will remember these images, and while you are jotting down the summaries, you will remember again my voice, and this my voice will translate in your mains. Okay, so it's like my voice will be there as an echo when you will be writing the answers in your mains hall. Okay, that's my ultimate purpose with everyone, jokes aside, but that is what we should aim for. Okay, memorization, photographic memory, so picturize this in your brain properly. Okay, so now let us move our discussion to the southern hemisphere too. Okay, let us move our discussion towards South America. So if I'm moving towards South America now, okay, on the west coast of South America, you have the world's longest mountain range. Okay, you have what? You have the world's longest mountain range. Okay, it stretches for more than 6,000 kilometers. Okay, it's not a joke, guys. It stretches for more than 6,000 kilometers. And there is a country over here, the world's longest country. The world's longest country is Chile. The world's largest country right now is the home of respected Putin, Russia, whereas the world's longest country is there in South America. It is called as Chile. Okay, and Chile has got some of the biggest national parks, or some of the lengthiest national parks anywhere in the world. Okay, so recently there has been a documentary called as the world's greatest national parks. If you ever get time, guys, please watch that documentary, world's greatest national parks. It has been narrated by the ex-president of USA, Barack Obama, sir. You can easily score 10 to 50 marks in your mains if you just go through that documentary. That is the visualization power of that documentary. Okay, I'm not bluffing. If you get time, please do watch that. Okay, so now let us move our discussion to the southern hemisphere. Okay, so if you see southern hemisphere, here you have one complete mountain range, this complete white belt. This is called as what? This is called as Andes. Okay, you do have a certain mountain range over here. This mountain range that you see, these are called as cordilleras. These are called as cordilleras. Okay, okay, you have western cordillera, you have central cordillera, and you have eastern cordillera. But right now just focus on the Andes. Okay, so the Andes, they start right from the southern borders of Ecuador and they extend till the southernmost tip of South America. And because of this, Andes will again act as orographic barriers to the oncoming westerly winds from the Pacific. And as they act as orographic barriers to this coast of Chile, again you will have what? You will have temperate, evergreen. You will have temperate evergreen rainforests. You will have temperate evergreen rainforests on this part of Chile too. Okay, so same thing. Now let us apply the same thing for Africa, and first of all let's see whether we can apply it to Africa or not. Okay, so if I'm moving towards Africa now, okay, so do you have land which is being intercepted in Africa? No. Why? Because you have what? you have Tropic of Capricorn passing through Africa like this, and the land to the south of Tropic of Capricorn, you have absolutely no land where it can be intercepted by the westerlies. So the African continent is devoid of what? The African continent is devoid of the temperate evergreen rainforests. You won't find temperate evergreen rainforests in Africa. So now let us pan our focus on Europe. Okay, so if I'm now considering Europe, okay, again, the zone of westerly winds is where it is striking over this part. Okay, so this is the region where the westerly winds normally strike, but considering the northern hemisphere and considering the movement of sun with respect to earth, okay, the apparent migration of sun with respect to earth, mind you, that migration is apparent. Okay, sun will migrate between Tropic of Cancer and Tropic of Capricorn. So if just imagine, if sun is in the northern hemisphere, all of the pressure belts and all of these winds will move northwards, and if sun is in the southern hemisphere, all of these winds move southwards. So there is a very peculiar type of climate which is seen in this part of Europe. Why? Because westerlies will strike this part only in the winters. I'm again reiterating, westerlies will strike this part of Europe only in winters. Why? Shifting of pressure belts. Those of you who are getting this, okay, those of you who are not getting this, I will be there to explain you everything. Now just listen to me and just try to grasp as many things as possible. Okay, this is a precursor, guys. I am just building up the information so that whenever we'll do the atlas, you all will be pretty comfortable. Okay, so this region of Europe will only come under the purview of westerlies in winters. Okay, so you will have rains only in the winter season in this part of the world, and this type of climate, this is called as what? This is called as Mediterranean type of climate, and the vegetation over here, it is called as Mediterranean vegetation. And again, you have what? You have no mountains as long as the Andes, as long as the Rockies, as big as the Pacific Northwestern Mountain Complex, who can basically stop them and cause rainfall. Okay, so in Europe, you don't have such kind of arrangement. So now let's focus our attention towards Australia and New Zealand. Okay, if you consider this very small island of New Zealand, I'm zooming in over in New Zealand. So if I again consider New Zealand, okay, this very small island, let me open up the 3D image. Imagine this is our, imagine what means this is New Zealand, and on the west coast of New Zealand, again you have a mountain range called as what? Called as the Southern Alps. Called as the Southern Alps. Okay. And what do these Alps will do? These Alps will again act as orographic barriers to the oncoming westerly winds like this. And New Zealand is one of the coastal areas, in the temperate regions where you will have what? Where you will have what? You will have mangroves. This is very, very astonishing, guys. Okay, mangroves are typical territory or the typical characteristics of the equatorial, littoral, or the where you will have the temperate evergreen rainforests. Yeah, I know there is no sound. Sound will now come. Okay, don't worry. Yeah. So New Zealand is a unique vegetation where you will have what? You will have temperate evergreen rainforest, but along with that, you will also have what? You will also have mangroves. You will also have mangroves. So please remember New Zealand from this perspective, that New Zealand is the only temperate topography where you will also have what? Where you will also have mangroves. So please keep this in mind, guys, that there are some regions outside the equatorial areas, outside the temperate areas, or rather outside the tropical areas, where you do have mangroves. And this is the primary region where you have mangroves. The west coast of New Zealand, it is called as the Haas Coast. It is called as what? It is called as the Haas Coast. So this is where I end up my discussion today. So if I'm quickly summarizing whatever we did today, so today, first of all, I introduce you all to the vegetation of the latitudes of 60 to 65 degrees north. Okay. After that, I introduced you to the vegetation of the temperate areas where you will be having what? Where you will be having the orographic side of the mountains acting as barriers. And because of this, on the orographic side, you will have evergreen vegetation, and on the leeward side, you will have what? You will have grasslands. Okay. So you will have different types of vegetation globally. So we are now only left with the polar kind of vegetation, wherein you have the tundra kind of vegetation, you have small mosses and lichens. So tomorrow I will just introduce you to that in 5 to 10 minutes, and tomorrow onwards we'll start focusing on the surface of earth. So I have covered the major climatic vegetations, the major climatic zones on a very basic level. We have covered what is the insolation received on different latitudes. We have tried to paint a picture of the global planetary events and the resultant vegetation. So now, tomorrow onwards, I'll be building up on the land surface. We will be also introducing a little bit of oceanography from tomorrow, and 5 to 6 classes afterwards, we will start with the detailed discussion of the maps per se. Okay. So guys, it's my humble request that those who are watching this lectures, please have Orient Black Swan School Atlas with you. Okay. Orient Black Swan School Atlas is pivotal. It's paramount for your preparation. So please keep that atlas open with all of you so that you have a working understanding of whatever I'm teaching and you can move forward with yourself. Okay. So I'm again reiterating my name for you all. Okay. My name is Pritesh Maturkar. Okay. You can join me on a Telegram channel called as Geography by Pritesh Maturkar. You can just do a global search at the rate Geography by Pritesh. Okay, this will take care of your current affairs. This will take care of whatever is happening in the field of geography from the current affairs perspective, and you will be pretty comfortable in dealing with mains per se. Okay, so here I sign off my lecture for today. I hope this lecture was enlightening for all of you, and I slowly will pick up our pace and we will cover the entire world's physiography through maps. Okay, so today you got some of the names like Rockies, like the Pacific Northwestern Mountain Complex, like the Andes, like the Cordilleras, like the Southern Alps. So slowly I'm introducing you to all the names. So bear with me, we will sell you through the end. Okay. So I thank you on the behalf of StudyIQ IAS English. I hope these sessions were enlightening. Please everyone keep on working hard and smart. That is a dire need of the time. Okay. See you all on the other side tomorrow sharp at 5 p.m. where we'll continue.